Welcome to this video for the Fundamentals of Math Learning Guide. In this video, we're going to focus on factors, both the greatest common factor as well as prime factorization. Now, if this is the first time you're seeing my face, hi, my name's Dr. Marissa May. I'm on a mission to help students feel confident in their math classrooms. So this video, this learning guide, those are just resources that I provide to students to help them understand and feel that confidence to do well in their math class. So don't forget to hit that like and subscribe button. That way you get a notification every time a new video is posted. So let's jump right in. For problem example number 1, I'm going to do prime factorization using a factor tree. Now, if you've never used a factor tree before, it's okay. It's not that intimidating. I promise we'll make it as painless as possible. Let's jump right in. So with a factor tree, what you're trying to do is to find two numbers that multiply to give you 54. It could be any two numbers. You don't have to start with the first two I start with, although you can. Now, you may be thinking, oh, 54. I remember 6 times 9 is 54. And so I would write it as 6 times 9. So I use it, make two little branches. Now, you're going to have to work on each of the branches here because now you want to ask yourself, okay, what two numbers are going to give me 6? Well, that's 2 and 3. And then what two numbers are going to give me 9? That's 3 and 3. Now think ahead, because if I wrote a branch here, the only two numbers that give me 2 and 1, 2 are 2 and 1. That doesn't really help me a little bit. It just kind of repeats itself, right? The only two numbers that will give me 3 are 3 and 1. So when you get what we call a prime number at the end of your branch, that branch stops. You don't have to go any further. So what we do then to write our prime factorization is we write all the ends of our branches. 2 times 3 times 3 times 3. Or we could write this with exponents. 2 times 3, and then we have 1, 2, 3 threes, so we would write it with an exponent of 3. Either one is okay. Just watch the instructions. Which one are they asking for? If they want it with exponents, then of course you would write it just like this. Now, when we look at example number 2, we're looking for the GCF. Now, that is an acronym that means the greatest, that means the largest, common factor. So you're looking for the biggest factor that these two have in common. I'm going to show you how to find this using, again, the factor tree. So let's start with 36, and we'll make a factor tree for it. And then we'll make a factor tree for 45. Now, the beauty of it is I already have a factor tree for 36. So we'll use that idea. And then let's make a factor tree for 45. Okay, so think of two numbers that will multiply to give you 45. Maybe you're thinking of 9 and 5. Okay. Now, 9, two numbers that will multiply to give me 9 are 3 and 3. And the 5, that's a prime number because the only two numbers that multiply to give me 5 are 5 and 1. So I know that part of the branch is done. Okay. Now, when you're looking for the greatest common factor, you're looking for the ends of the branches that are the same. So I see that 36 has a 3 at an end of the branch, and so does 45. So my GCF has got to have a 3 in it. But I also see that they have another 3 at an end of a branch. So I've got another 3. That means my GCF, my greatest common factor, has to be 9 because they had the two 3s in common, and that's what we're looking for. Well, friends, I hope this helps with our factors and finding factor trees. So much fun there. If you have questions or comments, be sure to leave them in the comments below. I am happy to help. Bye for now.